Thank you for watching Knowledge Academy. So before we start today's class, let's talk about what is calculus, right? What is calculus or what is derivatives? So first thing we're going to be talk about the calculus part before we go to the topic in this course. What is a calculus? It's basically a math of change, right? Math of change. Math of change, it could be, technically speaking, lines and a smooth curve. Okay? Lines and smooth curves. When I say lines and smooth curves, it means those are the ideal conditions. Okay, lines and smooth curve, those are the ideal conditions. Now, calculus also have two types or two branches. One is derivative, and the other one is calculus. Or we can, usually people stuck there and copy tables. Or generally people say integral calculus. Okay, so don't stuck when you say calculus, you complete or basically cover both derivatives and integrals. Okay, uh, now in ideal world, in ideal world, we consider ideal thing, we consider or absolute thing, ideal or our best case scenario, we consider them. We understand like this. Well, we understand flat thing well. What does that mean? It means if I say flat plate, if I say flat plate, you're going to draw something look like this. If I say make circles, I hope I can make the circles. You're going to make a circle like this, right? And if I say make like a box, you can make a box like this.
What is he talking about?
Somebody have any question? And if I say line, you can say line like this. Okay. These are the flat things we say is ideal things. But we are living not in an ideal world, we are living in a real world. So real world things are a little bit different. When we talk about the real world, we don't have a things like this. We have a things like that. I'm going to show you in real world. Yeah, in real world, the things are not smooth. It means line could be like this. Maybe line could be like this. Okay. Maybe the square is going to be distorted like this. Maybe the circular disc I showed you earlier is going to be look like maybe it's hard to make like this, and vice versa. You have some random shapes like right. These are the shapes. Now, if I go back here, I can use simple math. So I can do all my calculation. Like I say, do the area for this. You can do exact calculation. Okay, you can do exact calculation. But when things are not smooth or absolute or ideal, I cannot do exact. All I have to do here is approximation. Okay. Same thing here. If I think thing is not there, if I asking you, can you calculate the area of this? Yeah, there is no simple math to do the area for this. You do approximately, you can tell me. You know what, professor, is area is maybe 2.35 meters square. And if I use different technique, maybe it's 2.22 meters square, or maybe it's 2.49 meters square, and all are same because all are approximation. Okay. Now, I told you we have two things. Number one is derivatives, and the other one is integral. So we have our derivative calculus or differential calculus, and we have integrals or integral calculus. Does anybody have any question? Are you guys still able to see my screen, the one I'm drawing right now, the black screen?
Yes.
Okay, let's keep moving on. So what are you going to do? We're going to be talking about side by side. So I'm going to be just drawing it here. And I say, you know what? I'm going to assume differential calculus. And integral calculus. Differential calculus, integral calculus. So the example I gave you a few minutes ago, let's suppose pick up the line. Let's suppose I have a line like this. And I want to give you straight line. Unfortunately, I could not because I'm living in a real world. Real world things are not smooth, like a shape of a potato. Potato is not smooth. There's like some random crappy shape of all kind of potatoes. So if I give you a potato asking you, I want to paint the potato. How much paint do I need? What you gonna do? If I say I want to paint a potato, tell me how much paint do I need? You need to know exact area or surface area of a potato. So what I'm gonna do, I'm gonna be just saying some random shape here, like this. And I say that you have to calculate that the calculation of this shape. You stuck. So what you're gonna do, you say is where you want the calculation. Where? The differential calculus means where. And integral calculus means how much. Differential calculus means exactly where, at. This guy, at, where. Different integral calculus means how much. It means where to where, right? Where to where. There's two boundaries coming up in integral calculus. So I told you just like, you know what, pick this point C. So if you pick point C and you try to say point C like this, and you pick the point C and you make like a circle. And then you make this circle here, you make this circle a little bit bigger. When you say this circle a little bit bigger, this line, the line I show you, is going to be passing pretty much like this. Everybody follow up what I did. I just made like a little pink color circle and try to zoom out this circle. This is point C, right? Do you think the white color line I'm just passing, oh, sorry, not white anymore, but if the white color line I'm passing my cursor right now, it's a straight line, yes or no? The white color line I'm passing my cursor is a straight line.
No.
No.
No, it is not. So what I want to zoom in again one more time. I want to zoom in again this. And the little circle, the smaller circle, I'm going to bring it back here and make it again. And this time, it's much better. And I would say that, you know what? Screw this line. I don't want to do it again, this little thing. I'm going to consider this is my approximation. I'm says, you know what? Hey, I couldn't keep doing this zoom in, zoom in, zoom in. How much zoom in I'm going to do? I just consider this a straight line. And I'm just taking this yellow color line, right? And I'm going to just draw here, right? And basically, this line gave me the slope. And this slope is my m. You learn about the slope. And this m is actually dy over dx or dx over dy or dy over dt or dx over d, right? You guys learning about this differential, how to take the differentiation of different things. And this is exactly what you do. When you talk about differentiation, exactly what you do is you're telling me how much x, let's suppose here, I'm talking about this example. I'm going to say how much y change if x change. This is exactly what the differentiation means. How much y change when x change? At where? At c. At c. Because remember the point c is here. Everybody catch up this thing, what I just did.
Yeah.
Okay. Now, let's talk about the calculus side. In calculus, I want to take a random shape, maybe, let's suppose a shape like and somebody asking you to do the area, I says, how much? Remember, how much? And you say, well, don't worry about too much for this thing. Let's do one. Just go to that little shape and then make this shape. Okay. And we come back here and I make this white color box. So what I'm going to do, I'm going to make this white color box again. In this white color box, this yellow curve, in this white color box, I'm only interested in here, guys. I'm only interested in here. So I'm going to say, and I pick A to B, right? And then usually you write like this, A here, B here, upper limit on B, lower limit at A. And then there is a function of this, whatever function, this curve, you're going to put here. And then you're taking from this point to this point, A and B, putting over there. But here, the issue is that how can I differentiate this? So what you're going to do, this function based on how smaller I need those little things. So really, just let me just show. This AB is the whole limit. If the AB is not given, you're going to take one stick. This one stick. This one stick is going to be look like this. And this guy, you're going to call it dx. That's why you're putting dx here. So basically, you're saying same thing, same way, but when you're saying the differential calculus, how much y change when you change x, or how much x change when you change y, or how much y change when you change t, vice versa. Okay, here, look at that. The top portion is not split. So what I'm doing here, I make this little thing, and I call this approximation. Okay. So what we're gonna do in this course, pretty much we stuck both sides. In this course, we are stuck on both sides. Sometime I go here, sometime I go there. And I have to deal with that. Sometime I'm talking about this guy, sometime I talk about this guy. And sometime I say sometime. It's easy for me to talk about this every time first.
How much stuff do you
And
need?